Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 23, Episode 76, full broadcast on the 24th of July, 2020. Coming up on SpaceTime, alien stellar streams discovered in our own galactic neighbourhood, tracking satellites from the Arctic, and Red Planet Rush Hour, with 3 missions bound for Mars this month. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered a stream of stars close to our own solar system that didn't originate within our own Milky Way galaxy. A report in the journal Nature Astronomy claims this alien star cluster, which has been named Nix after the Greek goddess of the night, slices through the disk of the Milky Way in an arc extending some 6,000 light-years above and below the galactic plane. Early estimates suggest the stellar stream consists of at least 250 stars. Stellar streams are thought to be the remnants of globular clusters or dwarf satellite galaxies that have been stretched out along their orbit by the gravitational tidal forces of a larger galaxy before being disrupted. The data shows the Nix stream appears to be rotating with the Milky Way's galactic disk, but it's also moving towards the galactic center. The authors also detected an additional stellar stream, which they've dubbed Nix 2. It has similar motion and stellar characteristics to Nix, but opposite velocity, suggesting that it's related and might be debris from a separate passage of the same dwarf galaxy through the stellar disk. The authors made their discovery using data from the European Space Agency's Gaia satellite. They then ran that data through sophisticated computer modelling known as the Feedback in Relativistic Environments, or FIRE project, resulting in the discovery of Nix. Launched in 2013, Gaia is studying the movement of more than 1.5 billion individual stars across the sky, in the process creating an incredibly precise three-dimensional map of our part of the galaxy and nearby intergalactic space. The FIRE project uses deep learning algorithms and artificial neural networks in supercomputers to create a simulation of galactic evolution across time. The authors added differences between stars originating in the Milky Way from those accreted from beyond the galaxy to the FIRE program, and then included the Gaia data and crunched the numbers. The program successfully identified the Milky Way's galactic halo, which contains a lot of older stars, often in unusual orbits. And importantly, it also identified 2 previously known streams of alien stars. The Gaia sausage, which are the remains of a dwarf galaxy that merged into the Milky Way between 6 and 10 billion years ago, and the Helmi stream, the remains of another dwarf galaxy discovered in 1999 that has also been cannibalized by the Milky Way. The authors say Nix was likely once a dwarf galaxy or globular cluster that merged into the disk of the Milky Way at a low angle and in a prograde orbit. One of the study's authors, Linda Nassib from the California Institute of Technology, says it's either the remnants of a galactic merger between the Milky Way and another galaxy, or they're disk stars from the Milky Way that have been gravitationally perturbed into a new orbit following a collision between the Milky Way and another galaxy. It all nicely slots in with astronomy's understanding of galactic evolution. Galaxies grow through a process known as galactic cannibalism, a series of mergers and collisions with other galaxies. For example, the Milky Way is currently stripping matter from at least 4 nearby satellite dwarf galaxies. Two of those satellite dwarf galaxies, the Large and Small Magellanic Clouds, are connected to each other by a gravitational tidal stream of stars known as the Magellanic Bridge. And they're also losing material to the Milky Way through another bridge known as the Magellanic Stream. Then there's the Canis Major dwarf galaxy, which at 25,000 light-years is actually closer to our Sun than the centre of our own galaxy is. It's also being tidally disrupted by the Milky Way, with a filament of stars trailing behind it as it orbits around the Milky Way, forming a complex ring-like structure wrapping around our galaxy at least 3 times. And there's the Sagittarius dwarf spheroidal galaxy, which has already collided with the disk of the Milky Way on at least 3 occasions, and is losing more and more material with each pass. Of course, galactic cannibalism works both ways, with the Milky Way now destined to collide with and be consumed by the much more massive Andromeda galaxy M31. Andromeda is currently approaching the Milky Way at a rate of 110 kilometers per second. Depending on which set of calculations you believe, the cosmic collision is likely to occur sometime between 3.7 and 4.5 billion years from now. Nassib and colleagues' next job will be to use ground-based telescopes to obtain detailed spectra from the stars in the Nix stream in order to determine their age, exactly when they joined the Milky Way, and to understand their chemical composition in order to see exactly how they differ from the stars that form the Milky Way. This is SpaceTime. Still to come, tracking satellites from the Arctic and Red Planet Rush Hour with 3 missions bound for Mars this month. All that and more still to come on SpaceTime. The European Space Agency's Operations Centre in Darmstadt, Germany, operates a number of satellite tracking stations known as S-Track, the European Space Tracking Network. These stations support various ESA missions and facilitate communications between mission managers on the ground and spacecraft such as XMM Newton, Mars Express, Bepi Colombo, Gaia, Solar Orbiter, the Copernicus satellite constellation, and the Galileo satellite navigation system. Many of the satellites that gather information on the health of our planet, helping with the world's transportation and navigation, and undertaking important scientific missions, are on what's known as polar orbits, which take them over the planet's north and south poles. And keeping in touch with spacecraft as they fly over these desolate and remote areas isn't an easy job. While SpaceTime listeners would be familiar with the European Space Agency's New Norcia tracking station near Perth, ESA operates similar stations in Spain, Argentina, Sweden, Kenya, Belgium, the Azores, Chile, and the Kourou Space Centre in French Guiana. But none are as isolated or in such an inhospitable and desolate environment as Svalsat, ESA's most northerly ground station. Located on a windswept mountain plateau on the island of Spitsberg in Svalbard, Norway, well above the Arctic Circle, the complex of more than 24 dishes is a vital link, collecting data and communicating with the missions flying above them. As well as ESA, Svalsat's also providing satellite communications for NASA, NOAA, the US Geological Service, the Norwegian Coastal Administration, and the space agencies of multiple countries, including Taiwan, South Korea, India, Germany, Italy, and Japan. This report from ESA TV.
Auroras dancing above these satellite antennas at the Svalbard satellite station high in the Arctic. Here, next to one of the most northern cities in the world, is the perfect location to track polar orbiting satellites, including some for the European Space Agency.
Here at the KSAT station at Svalbard, we have about 80 tracking antennas. This station is very unique. We have a perfect location for tracking polar LEO spacecrafts. And the main reason being that we can see 14 out of 14 daily orbits.
The spherical radomes protect the antennas from the harsh weather conditions of the Arctic environment. Inside, the antennas work like any other ground station, following a satellite to collect its data, check its health, and send commands back. Data from ESA's Earth explorers, such as Aeolus and SMOS, are downlinked to Svalsat, as well as from the Sentinel satellites for Europe's Copernicus Environment Monitoring Program. 8 of these antennas are dedicated to tracking the Copernicus Sentinels.
The visibility of these Sentinel satellites up here are about 14 minutes from the time they come up from the horizon and the time they are not visible longer. And during that time we download the payload data, the housekeeping data, and sometimes we speak to the satellite. That means commanding the satellite.
In addition to the Earth observation satellites, the ground station also supports Europe's Galileo network for navigation, as well as for search and rescue. While this location is optimal for communicating with the satellites orbiting close to the North Pole, the snow, cold, and long periods of darkness makes life for people working here a challenge. To ensure that the environmental conditions do not affect the ground operations, teams of 2 people work in 24-hour shifts to monitor each satellite pass.
All the data from these satellites are very important for a lot of people around the world when it comes to the weather, the health, the future of the planet, of course. So it's really nice to be part of that and to help people get this information and distribute it.
Across the globe, teams at ground stations work around the clock to download vital information and track the health of satellites that are checking the health of our planet.
And that report by ISA TV included Svalstat Station Director Ole Petter Stromstad and KSAT Sentinel Service Manager Jenny Janssen. This is SpaceTime. Still to come, Red Planet Russia with 3 missions bound for Mars this month. And later in the science report, news that the virus that causes COVID-19 has been found to be structurally different from its nearest bat virus relative. All that and more still to come on SpaceTime. Well, it seems to be rush hour on the road to Mars with 3 missions currently targeting the red planet. NASA's Mars 2020 Perseverance rover has just been mated to its Atlas V launch vehicle in preparation for its flight from Space Launch Complex 41 at the Cape Canaveral Air Force Station in Florida, slated for July 30. It had originally been scheduled for launch on July 17th, but had been put back 3 times. First to July 20 because of a faulty crane, then to July 22nd after a potential contamination issue was identified with ground support lines, and finally to July 30th after a liquid oxygen sensor line presented off-normal data during a wet dress rehearsal. Mission managers deciding additional time was needed in order to understand and resolve the issue. At this stage, there's no panic as the launch window to Mars remains open until at least August the 15th. These are designed to provide the shortest journeys between Earth and the red planet, which is based on how the orbits of the 2 planets line up, and they line up best during a narrow window every 26 months. The 6-wheeled robotic Perseverance rover will land on an ancient river delta in the 45-kilometre-wide Jezero crater in the Martian Northern Hemisphere on February the 18th next year. And that touchdown date is set firm, regardless of which date it launches. Once Perseverance has wheels on the ground, it'll search for signs of past life, study the local atmosphere, weather and geology, and collect samples for return to Earth in a future joint NASA-ESA mission slated for 2031. It'll also test new technologies, including oxygen harvesting equipment, new materials which will be used during a manned mission to the red planet, and it will even launch a little helicopter named Ingenuity. Perseverance is based on the existing Mars Curiosity rover, which has been exploring the nearby Gell crater since its arrival in 2012. But NASA isn't the only agency on its way to Mars. China's Tianwen-1 or Heavenly Questions mission is also bound for Mars, flying on a Long March 5 rocket from the Wenchang spacecraft launch site on Henan Island in the South China Sea. It includes both an orbiter and a lander rover. The lander rover's design appears to be borrowed from NASA's Spirit and Opportunity rovers. In order to reach the surface, the lander will use a parachute, retro rockets, and ultimately an airbag for final touchdown. Meanwhile, a Japanese H-2B rocket is carrying the United Arab Emirates HOPE satellite. The 1,350-kilogram satellite will study the Martian atmosphere from orbit for a full Martian year, 687 Earth days. HOPE carries 3 primary science instruments, an infrared spectrometer to measure the lower atmosphere and analyse the temperature structure, a high-resolution imager to study Martian ozone levels, and an ultraviolet spectrometer to measure atmospheric oxygen and hydrogen levels. A fourth planned mission to Mars, the joint European Space Agency Russian Roscosmos ExoMars mission, was also expected to launch this month, but has now been postponed to 2022 due to a range of technical problems compounded by the COVID-19 pandemic. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. New researchers concluded that SARS-CoV-2, the virus that causes COVID-19, is structurally different enough from its nearest bat virus relative that it's most likely the result of two or more distinct coronaviruses combining. A report in the journal Nature, Structural and Molecular Biology analysed the spike protein which enables the virus to bind to and enter human cells for both SARS-CoV-2 and the closely related bat virus RATG13. They found that although the structures were similar, SARS-CoV-2 has a more stable form of the spike lysoprotein and is able to bind approximately 1,000 times more tightly to the human ACE2 receptor protein. The study suggests that a bat virus similar to RATG13 would be unlikely to infect human cells, which supports the theory that SARS-CoV-2 is actually the result of two or more viruses swapping DNA. Now, for those conspiracy theorists out there, there's nothing sinister about that. These sort of events, known as recombination, occur quite commonly in nature. For example, when two viruses infect an intermediate host animal. But on the other hand, it can also be made artificially in a laboratory. A new study looking at socially similar European countries has found that the number of COVID-19 fatalities tends to be lower in areas where tuberculosis vaccination is more prevalent. The findings, reported in the Proceedings of the National Academy of Sciences, took into account variables like population density, access to healthcare, and the stage of the COVID-19 epidemic. Now, this observation isn't enough to confirm that the tuberculosis vaccination gives protection against the COVID-19 virus, but the authors are pointing to an ongoing Australian clinical trial as a possible source for more solid evidence. We'll keep you informed. The World Meteorological Organization predicts the annual average global temperature is likely to be at least 1 degree Celsius above pre-industrial levels for every year over the next 5 years. And it also warns that temperatures will be more than 1.5 degrees Celsius higher during at least one of those 5 years. The predictions take into account natural variations as well as human influences on climate. However, the research does not take into account changes in emissions as a result of the coronavirus lockdown, although the impact of the drop in emissions this year is not expected to lead to a reduction in overall carbon dioxide atmospheric concentrations, which is the driving force behind global temperature increases. A new study claims the world's population will reach 9.7 billion by 2064. The findings, reported in the Lancet Medical Journal, also suggest that the global human population will then start to decline to around 8.8 billion by the turn of the century. The new computer model estimates are around 2 billion lower than previous studies have suggested. Researchers say that by 2100, predicted fertility rates in 183 of 195 countries will no longer be high enough to maintain current populations without liberal immigration policies. And 23 countries could even see their populations shrink by more than half, including Japan, Thailand, Italy and Spain. The study also predicts dramatic declines in working-age populations in countries including India and China, which could curb economic growth and lead to shifts in global powers. Well, if you've been hearing some eerie moans and groans coming from the attic or basement, you're not alone. It seems there's been an upsurge in claims of paranormal activity in residential homes ever since the COVID-19 lockdown began. While rational people could put that down to spending more time at home and so having more opportunity to hear the house settle or expand and contract with changes in temperature, others insist there's something strange in the neighbourhood. So, who are you going to call? Well, Tim Mendham from Australian Skeptics, of course.
The story goes that, yes, there's a rise in paranormal activity, and as someone said, the more I'm stuck in this house, the more there's a feeling, as one person said. It's a wonderful example, this article, of logical fallacies, where they don't understand what they're saying. Paranormal activity, they're talking about a surge of strange things happening, but there's no surge of strange things happening. It's just a surge of your time you're spending at home. So the little noises and things that the flesh is heir to, that buildings creak, etc., which they do all day long and all night long, if you're there more time, you'll hear them more often and you'll think that they happen more often, which they don't. You're just aware of them. So it says more about yourself than about the paranormal hauntings and that sort of stuff. Another thing that someone said, which is classic believer philosophy, they were talking about, I'm a fairly rational person, said one person. I try to think, what are the reasonable, tangible things that could be causing this? But when I don't have those answers, I start to think maybe something else is going on, which is a leap in the dark by saying maybe something else is going on. Maybe you just don't know. And when I don't have those answers, you stop it there and you say, I don't have the answers. You can't say, I don't have the answers, therefore this is happening. Like, I see a light in the sky, I don't know what it is, therefore it's an alien craft. Things happen, I don't know what it is, therefore God exists and did it. Seriously, all these sort of different things that people make these leaps from don't know to do know, but it's made up something do know. And it's a very strange, as I say, a logical fallacy where people often make this mistake that because I don't know, it must be this, and it doesn't follow. Because you don't know, full stop. You just don't know. And unfortunately, you're going to have to leave it at that.
I guess it's also a case of people often don't know how little they really don't know.
Yeah, they often underestimate or overestimate. What's the Dunning-Kruger effect?
The Dunning-Kruger effect.
People who don't know think they do know a lot, and people who do know a lot don't think they know a lot.
The more you know, the more you realise you don't know it.
But it's also wonderful. If you knew everything, you'd stop. I find the don't know lots more fun than the do knows half the time.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favourite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/SpaceTime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.